Let's talk briefly about rounding. Rounding is a way in which we can dial in the precision of a number in the decimal system. What is precision? Precision is not the same as accuracy. To put it very esoterically, you could say precision is a necessary but not sufficient condition for being repeatably accurate. So one way you could put it is precision is the resolution to which you can give a measurement. So an instrument that allows you to measure to the nearest inch is more precise than one that allows you to measure to the nearest foot. All right. And when I say it's a necessary but not sufficient condition for repeatable accuracy, what I mean is you can't dependably get an accurate result without a certain degree of precision in your instruments. But it's not sufficient either. We can have something be very precise, as in the case of the guy who shoots a perfect dart game, but over here on the dartboard. Yes, so you get a perfect cluster over here that just takes some seriously precise aiming. He's definitely got a good technique, but he needs to dial it into the center. Yes, so here's an example of precise but not accurate. All right, enough about that. So when we talk about precision in our measurements, and this is all related to significant figures and so forth in your calculations and all that, what you need to think about is, now in the decimal system, is what place you can actually measure to. And we'll talk about that when we talk about sig figs. For now, let's talk about rounding in general. So you can, when you round, you'll have different considerations that will determine what precision you can report the number to. So say, for instance, I want to round this number to the hundreds place. Remember, of course, after the decimal place, we have the tenths, hundreds, thousands, and so forth. So if I'm interested in rounding this to the hundreds place, that means that this is going to be, this is the place that's the last place that's going to have any information in it aside from just, tacked on zeros. It'll remain a 6, provided the number after it is 4 or less. If the number after it is 5 or greater, it'll go up to the next number, to 7 in this case. So that's the algorithm, if you will. Identify the digit that you'll be rounding to, the digit that's in the place you'll be rounding to. Look at the one after it and determine whether or not you're going to stay at this number or go up by 1. In this case, since the digit after the 6 is a 2, this number becomes rounded to 143 and 56/100ths. Then another example would be, say, if I wanted to measure around this number, 47.4, 47 and 4/10ths. I want to round that to the nearest whole. All right, so the nearest whole, the ones place, is what we're worried about in that case. And I look at the one after it and see that it's a 4. It's less than 5. Therefore, this will remain a 7, and everything after becomes normally with whole numbers, we don't need to throw the decimal point on the end. That's an extra complication. Let's say I wanted to round this number to the nearest whole number. Well, now again, I'm looking at the wholes, the 7 there. And then I investigate this, the one after, and find that it is greater than 4. It is 5 or greater. Therefore, proper way to round this, 158. One more situation we have to consider is something like this, a number in which rounding will cause some carrying up the line. And this segues nicely into a discussion of significant figures. So say I want to round this number to the nearest hundreds place. Well, here's the hundreds place. There's my next place there. It's greater than 4, and so therefore, rounding this is going to make this go up 1, but then of course that's going to carry and make this go up 1, which is going to carry and make this go up 1. So 474. And here's where I mentioned significant figures, because if you're actually reporting this number, it's appropriate to leave those zeros there to show that that's the place we rounded to.